Magnetic field. If you have ever wondered how a compass works, so a compass is actually a detector that detects magnetic field that exists in space. What is something that is not tangible? You cannot see it, you cannot feel it. However, an instrument can help us detect and figure out that there's a magnetic field. That's a traditional detector. So here's a question. A magnetic sensor can be found in what? Is it a microwave oven, refrigerator, TV? The answer is smartphone. Yes, our smartphone has a magnet in it. It can tell the direction just like a compass does, and it has more functions. As a matter of fact, the Earth is a big magnet. So if you look at the Earth, it represents a magnet. What's really interesting is the north side, that's what we define as the magnet's north side, it's actually on the south pole of the Earth. And it's slightly off. The angle is slightly off the spin axis. This is Earth's spin axis. And the south side of this magnet is on the North Pole of the Earth. So this is the geographic North Pole, but this is the magnetic South Pole. Interesting, right? So if you have a compass, the direction north shall point to the north of the Earth, the North Pole of the Earth, which is the south of the magnet, which means two magnets, south always attract the north of another magnet. So the compass north side will be attracted towards the North Pole, which is what we commonly observe. So let's take a look at the magnetic field of a magnet. We use a vector. After the observation, we say like, okay, let's use a vector to represent this magnetic field that exists in the space. The direction of the magnetic field is always from the north side of the source, which means the one that caused this magnetic field. Remember the cause-effect relationship in this case. This magnet is the one that generates this electric field. So the north side of the magnet is where the magnetic field line originates that represent magnetic field. At this point, directs along a line that's tangential with this curve, along the tangent direction of the curve. So at this point, it points towards a tangent direction of the curve. So at every point, there's a direction of the magnetic field that's along the tangent of this magnetic field line. That's the direction, and the unit is Tesla. So do you think the unit is named after the car? And who is this genius in the picture here? That's a question for you to think about and do research on. Magnetic field, when we use them, we use these representations to denote them. In the first example, magnetic field in represent the magnetic field vectors are perpendicular to the direction of your screen or the paper pointing inside, away from you, into the paper. So this is what we call the magnetic field towards the paper. And this one, magnetic field out, represents, so these dots represent the direction of the magnetic field vectors. They are perpendicular to the surface and pointing outwards. So the dot is similar to the head of the arrow, and the process similar to the back of the arrow, meaning going away. Okay, the other two cases are more obvious, and we're more familiar with this. So here's a magnetic field vector pointing towards the right direction, magnetic field vectors pointing towards the down direction. So these are some different representations. In summary, we talked about magnetic field. What is the field that exists in the space and the sensor that you can detect it, and talk about the direction of the Earth magnetic field as well as the north and south side of the magnet. We talked about the symbol for magnetic field, B, and also the direction of the magnetic field in the magnetic field diagrams, as well as the unit. And last but not the least, we talked about the direction of magnetic field in different directions represented when we put them on paper in a diagram.